Hello everyone. In the last video we have seen that how we write outcome of coin and a dice or two coin or two dice. So if you have not watched that video you can watch it now or watch it later also. So today we are going to understand about the encoding. How we will encode a message using what we learned earlier yesterday. So first question, how much information a coin hold? Means how much information we can hold using a coin. And second question, how much information a dice can hold? This is a very typical question which is asked by many of you, means how much information we can convey using coin, a single coin. So suppose we want to codify black and white using coin. We all know that coin has head and tail. Okay, and how many item we have to codify it? One is black, one is white. Can we assign black color to head? Definitely. Can we assign white color to tail? Now, whenever anyone asks about black color, suppose I am writing this this shirt is black. So what I will write? This shirt is edge. Here what edge represent? Edge is representing the black color. Now what if I want to write the shirt is white? So I will write T instead of H. Okay. Now what if there are four color: red, blue, yellow and green? Can we codify it with the help of only one coin? Let's see. Let me write red, blue, yellow, one second, and green. Okay. Suppose I give red color as head, blue color as tail. Okay. Now what can I assign yellow as head also? Let's see. And green as tail. Okay. Now what will happen if I say this shirt is red? Okay, in place of red, if I write this shirt is head, means edge. Is it showing a right thing? It can be yellow also, no? Because yellow is also representing edge. So can we take another coin? Let's see another coin and try to represent. Suppose I represent this as head, and this as tail, and this as tail. Taking the second coin. Okay. Now I will write this shirt is edge. Can you understand from here that what this edge represent? This is representing red color. What if I want to write this shirt is blue? This shirt is blue. Can you comment your answer? And I will give a heart sign if you have given the correct answer. Okay. Same you can do for other yellow and green also. Now moving to, suppose we want to codify all the color of rainbow with coin. How many coin required? Now look at this table. Okay, here are color red, orange, yellow, green, blue, indigo and violet. Okay, so we have already seen that we required one coin to codify two color and two coin to codify four colors. So since there are more than four color, we definitely need one extra coin. Okay, so let's start codifying the red. So we will write head, head, head. Okay, this will codify red. Then we write head, head, tail. This will codify orange. Then we write head, tail, head. This will codify yellow. Then we write head, tail, tail, and this will codify green color. Now we write tail, head, head. This will codify blue. Now we write tail, head, tail. This will write indigo. This will codify the indigo color. Now if I write a code for violet, then it will be like T, tail, tail and head. There is very easy way to write this thing without remembering. Suppose there are four coin. So how you will write this? Okay. So let me show. Just a short trick. There are means there are three coins. Okay. So 2 to the power 3. What is 8? Okay. So what we do, we divide it by 2, we get 4. So we write 4 head, 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 and then write 4 tail. Okay. Now we write 2 head and 2 tail. This is a shortcut. Again 2 head, again 2 tail. Then we write head, tail, head, tail, head, tail, head, tail. Okay, you got all the combination. So I think we have utilized this 7 combination, and we have left not used this one, means all tail combination we have not used. Okay. So suppose if you want to say that particular color is green, so you will code like this H T T, and any person can get that, yeah, that thing is particular thing is green. Okay. Now moving forward, how many dice required to codify this rainbow color? Till now we are codifying everything with coin, with the help of coin. Can we do that with the help of dice? Because in the earlier video we have seen that we can miss even dice has 6 combination. 1, 2, 3, 4, 5, 6. A dice has 6 outcome, means we have 6 things which can codify this. So suppose I start rolling dice and I get 1, then I will say it red color. If get 2, then orange. If get 3, then yellow. If got 4, then green. If got 5, then blue. If got 6, then indigo. Now I have only 6, but I have left with the violet color. So I will again repeat 1. But here red has also 1, violet has also 1. So there will be a quite confusion. Okay. So Can we take another dice? Okay. So if we take another dice and if we get 1, then red. Means if both get 1 1, then it will be red. If first get 2, second got 1, then orange. If first got 3 and second got 1, then yellow. If first got 4 and second got 1, then green. If first got 5 and second got 1, then blue. If first got 6 and second got 1, then it will be indigo. But now the case, if we write 1, then again it will be repeated. So if first dice get 1 and second dice get 2, then we will say it as violet. Okay, now you can see that we have a lot of redundancy, means we have not used many of things, right? Means many of the bit are left, means here 2 through 6 everything we have not utilized. Okay, so what happened to this? Yeah, they are unused bit. We do not use them. We, yes, we can make them work like this. Suppose 1 1 is representing this, 1 2 can also represent this. Means we can assign another bit to represent the same item. Mind here, no, means no two bits should be same. Means here, suppose here 2 1, so 2 1 should not assign to blue. It will create a confusion. Else, if there are different bits, then we can assign. So I have already told about how to utilize the unused bit. So we have now idea that something which has two states carries the smallest amount of information. Means we have a coin which has two states, head and tail, and through which we can only define two items. There we were defining black and white. Okay, so one question to you. Can you represent alphabet with the help of dice or coin? There are 26 alphabet. Okay, so this is a sort of homework. Can you represent this with the help of dice or coin, or you can combine dice or coin? So write in the comment how many dice or coin required to represent it. Which will be the most appropriate coin or dice for solving the above problem? Yeah, you can utilize coin and dice also. Suppose suppose coin get head and dice get 1. Suppose coin get head and dice get 2. Like this also. Okay, so you can apply this approach and just write your answer in the comment. Now we will move forward and look at physical bit. Till now everything we have seen are numerical. Head, tail, 1, 2, these all are numerical and booleans. So now we have many physical system which has only two state. Already seen. We have already discussed this in the case of head and tail. There are two states. Have you ever used the CD or DVD? I know now it is not being used. We have pen drive and SD card, but you might have seen the CD and DVDs. They use similar approach where CDs are burned and whole are generated. These are called pits, and the unburned section is called land. If you look at this image of CD, you will see that this area, this unburnt area is known as land, and this portion which is burnt is known as pits. So physical system with more than two states can be treated as only having two. Suppose there are more than two physical system. Means suppose if we are talking, consider the case of voltage. We know that we have 0 volt, 1 volt, or even 1.5 volt also. So there are many voltage, different voltage, but we are only considering 0 volt and 5 volt. Okay, so let's see this table. Suppose there is a physical system. First physical system is coin. Okay, so it has two state, head and tail. Suppose we are talking about switch, bulb. So it has two state, off position and on position. If we have disk, then it has pit or land. If we have voltage, then it is 0 volt or either 5 volt. Now can we write it in a binary form? Suppose it is head of pit and 0, so we codify it as 0, and suppose if it is tail on of 5 volt or land, then we codify it as 1. Okay, so we can say that any two state system can be represented in the form of 0 and 1, and these are called as the binary digit. 2 binary means 2 digit. Okay, so since we use binary digit a lot in the computing, it is sometimes called as bit. So bit is just a binary digit representing 0 and 1. Now see this statement. A bit is the smallest unit of classical information. Means every information is stored in the form of 0 and 1. In this video, we have understand about how to codify the color. Okay, now we are not only codifying the color, there are many things to be coded, and we required many 0 and 1 in that set. So we will be understanding all those things in our next video, where I will be teaching you about binary number, conversion from decimal to binary, and binary to decimal conversion, and various hexadecimal conversions, and we will also look at ASCII code. So I will see you in next video with the following topic. If you have not subscribed to my channel, you can subscribe it. You will get all the latest video whichever I post in this. Okay, thank you for listening this boring lecture. Goodbye.